Okay. All right, so let's use those definitions to talk about whether a function is a power function, a polynomial function, both, or neither. Okay, let me sort of squeeze in the definition so we can see it all on one page, all on one screen. All right, what do we think about example 1? Power function or polynomial function? And how do you know? Polynomial, right? It's got more than one term, so there's no way it's a power function. But we also have to check, like, this is a power of 5. Is 5 a non-negative integer? Yeah, 5 is non-negative integer. 3 is a non-negative integer, but what's the power for x here? It's 1, and 1 is also a non-negative integer. So n is non-negative integer and more than one term. So it is a polynomial. Okay. What about example 2? Power function or polynomial or both or neither? Okay, and number 2 is the g of x, 2x squared times 4x cubed. Okay. Okay. So can we simplify this g of x? First of all. Okay, Isis, how would we simplify this? Or rather, when we simplify it, what does it give us? Okay, we add the exponent, so we'll get x to the 5th. And what's the coefficient? And multiply. So 2 times 4 gives me 8. Okay, so I simplified. Now, I know that it could be a power function because it only has one term. Okay, so this one is a power function, but technically it's also a polynomial because polynomial can have multiple terms, but it can also only have one term. Like, that's okay. So in this case, this one is actually both. Okay, so sometimes they could be both. What about example 3, the h of x? H of x equals 2 to the 5th minus 1 and over 3x squared plus 4. All right, you say a polynomial. Anyone else want to chime in about example 3? This one, example 3, is actually neither. Okay, but this is what we're going to study at the end of chapter 3. So this is actually something when we're dividing them. So when we divide polynomials, we actually get something called a rational function. Okay, so this is not a power function and it's not a polynomial. Now, Eric, back to your earlier question. Yes, polynomial means multiple, poly, right? But it includes groups of functions that only have one term or only have two terms or only have three terms. So that's why like it could have multiple terms, but it could also just be like one of them. That's also okay. All right, so polynomial really refers to a whole group of functions, and in that group, it's okay to have only one term. All right, let's take a look at this last one example for power function, polynomial, or neither. All right, why do you say power function? Why do we think this is a power function here? Okay, yeah, I mean, I buy that this is x to the 1/2, which means it's not a polynomial, right? 1/2 is not a non-negative integer. Okay, but let's look back at our definition of a power function. In fact, let's look right there. A power function can only have one term. This one has two. It's got the square root of x and the 3x squared. Okay, so this one is also neither. Right? All right. So there's one last thing I want to talk about here. That is our degree and leading coefficients. All right. So like I said, we're going to focus on the polynomial functions. That is the focus of 3.3 all the way to 3.6. So let's look back at this definition, right? So I said, hey, here's this polynomial function. It's got a whole bunch of terms in it, but it could only also have one. That's okay too. But we want to make sure we know that in general, we arrange them so the powers go from the biggest power to the lowest power. Okay, we go from the biggest power to the lowest power. So we can kind of see that how this is like the x squared and then the first power and the 0 power, right? So it could go up as high as we have in whatever problem. But some vocabulary that's important is this, that the biggest power, okay? So, sorry, this is the term with the biggest power. So the term that has the biggest power, the number in the front, that's your leading coefficient, okay? And the power of that biggest power, that is the degree of your polynomial, right? So it's really important that when we look at this, we know that we have to either FOIL everything out or we have to look for the biggest power, okay? So let's actually take a look at example number 6 real quick. Everybody see example number 6 down there? It's got the 4x squared minus x to the 6th plus 2x minus 6, okay? This one is in a form called standard form. We can think that standard form is already FOILed out for us. Somebody did the work, they FOILed it out for us, okay? If it's in standard form, the only thing you need to do is make sure you line up the terms from biggest to smallest. So what is the leading term for this polynomial? Yes, negative x to the 6th. What's the next term? Like if we line them up in order from the biggest term to the smallest term, yeah, positive 4x squared plus 2x minus 6. Okay, so this is just lining them up in order, but really the one we're interested in is that leading term, the term with the biggest power. So this term, that tells us the degree and our leading coefficient. So in this case, our degree is 6 because that is the power of the highest term in standard form. The leading coefficient, what is the number in front of this leading term? -1. So that, my folks, is your leading coefficient. Okay. Now, we've got examples 5 through 8 here. Which other example is given in standard form? Number 8, good. Okay, so this one is also in standard form, right? Which again means it's already foiled. Okay. Do a quick scan. Looks like it's already in order. So we can just say, hey, here's my leading term. So my degree for this polynomial is 5. And my leading coefficient is a positive 3. Okay? Pretty straightforward, I think, with the standard form. Now, let's look at the other two examples, okay? So let's go back to number 5. This one is in factored form, okay? That means that it is not foiled. If you were to foil, okay, the way that you find your leading term is you pick the biggest power in each one. So this one is x. The biggest power in the other one is x. If I FOIL x times x, I'm going to get x squared. But in this case, I don't just get an x squared, I get a negative x squared. If all I want to know is the degree and the leading coefficient, I don't need to FOIL anything else out. But I do need to find that leading term. Okay? From here, I can tell this is a degree of 2. And my leading coefficient is -1. Okay. All right, let's take a look at this last example, number 7. Number 7, definitely not standard form, right? We know that this is factored form. If you were to FOIL out, which terms would you multiply to get the leading term? The 3x squared, yeah, negative 3x squared, this x and that x. Yeah, good. Now, if you FOIL that out, you would get negative 3x to the 4th plus a bunch of stuff that doesn't really matter for the degree and the leading coefficient, okay? That means that our degree is 4 and our leading coefficient is negative 3. Okay? All right, so I know this has been a jam-packed Monday session, right? But this should get you through everything you need for quiz number 5, all right? So a little bit on determining the degrees and the leading coefficients, some stuff on our complex numbers with the I, remember, so like I squared is gonna give you -1. And then going all the way back to where we were 3 hours ago. I know it's a long time, but 3 hours ago when we learned about inverse functions and radical functions, okay? So all of that should help you get started on that quiz, okay? So don't forget, we've got like Monday, Wednesday, or Wednesday, Friday, things are due, Sunday night, something's due. So those deadlines aren't gonna change during our time together. So let's make sure that gets into your calendar so you don't accidentally miss assignments or anything, okay? So I'm gonna stop sharing my window here. And I've got one quick announcement before we finish up here, okay? So the announcement is around the exams. So I know a lot of you signed up for test correction, or sorry, not for test corrections, for check-in, okay? So I know that some of us did well on this first exam. Some of us didn't do as well as we wanted to. Some of us came into this class knowing a whole lot. So that's something I wanted to keep in mind is like sometimes when we compare ourselves to other people, we literally don't know where they've been, how, like maybe they had a way better math experience than we had. That doesn't mean that you're worse at something than someone else just because they've had a better experience in the past, okay? So for this exam, okay, and this is a one-time deal. This is not a deal that extends to every other exam, okay? For this exam, if you would like to buy back up to 50% of the points you lost, okay, you can do the following, right? So if you would like to buy back up to 50% of the points you lost, you can do the following. You can make test corrections, okay? So you will go back, look at your mistakes, and redo the problem so it is correct. Then you explain what your misconception was. Okay, so it's two parts. One is you make your correction, but two, I want to know that you know what went wrong and how to avoid that in the future. Okay. If you want to do test corrections, right? Anyone can do test corrections. You got a 99, you could do test correction. You got a 32, you can do test corrections, all right? But test corrections are due by Sunday, September 6th, so this upcoming Sunday, midnight, all right? So it's the same as homework number 3. You can email those to me directly at sdccd.edu. Okay, so email me directly. There's no place to go back and resubmit your test. But that is your opportunity to help with this first exam. If it was just like, I think the first exam with any instructor is hard, and the first exam in college with a new instructor is hard. Okay. If you want support around your test corrections, you can come to office hours. We'll do test corrections together. You can go to Val sessions, do test corrections there. All right. So those are opportunities available to you. If you're like, I don't really want to do test corrections, okay, that's your choice. You don't have to do test correction. But just so everyone knows, that there is the option for your final exam. Your final exam can replace your lowest test grade. Okay. So let's say you totally bombed this test, but every other test you figured out a good studying technique, your final exam can replace your lowest test grade. Okay. Now, here's the catch though. Only if you are regularly in class, that you are submitting quizzes and homework. So some of you have already started off this semester missing a whole bunch of assignments. If you continue to not do a whole bunch of assignments, you lose your privilege to have your final exam replace your lowest test grade. Okay, so yeah, it's a thing, but if you don't follow up on all the other pieces of being successful in this class, then you lose that privilege of having your final replace your lowest test grade. I will be explicit with you during your check-ins about whether or not you are in danger of losing that privilege. Some of you are already on your way. All right, so it's not too late to turn around and make a different choice, but just know that you missing a few quizzes and a few homeworks and then not showing up to class can lead to losing an opportunity to change your grade a lot in the past. Okay, so don't be in that boat. I don't want you to be in that position. All right, so you're welcome, you're welcome, you're welcome. Can you do the test corrections? And then at the end, if you still do well in the final exam, can you still replace your lowest test grade? Yes. All right, so you can bump this up to as high as you can get with your 50% back, okay? And you can still have an exam replace your lowest test grade. But here's the thing, folks. Everybody's got to take every test. You can't just skip a test and be like, I'll just get a 0 for it. No. You skip the test, you lose that privilege. Okay, so you have to take every exam. All right. I want you to take every exam because I've had students who get to my Calc 1 or Calc 2 class and they've kind of skipped a few things along the way. And then we get to that part and they're like, I never learned it in the past. And I don't want you to be in that situation. Okay, I want you to walk into Calc 1 owning that curriculum and feeling really good about your chances of success. Okay. So that's it for the announcements on the test corrections. Okay. If you don't want to write out your explanations, you're welcome to make a video of you explaining these to me. I won't show it to anyone else, but if you'd rather make a video and explain in words, then write it out. You're also welcome to do that. Okay. Cool. So I will, during my lunchtime shortly here, I will upload all your exams so you can take a look at your actual questions, what you got right, what you didn't get right, and we'll kind of go on from there. Okay? All right, folks. So I apologize for keeping you after on a Monday, but have a great rest of your day. Be well. Val's got a session starting pretty shortly here from 1 to 3, and I'm available on Wednesday morning for office hours if you need any help, okay? All right, folks, have a good rest of your day.